Hello.
Hello. Hello. Can you
Hello.
can you hear me?
Yes,
Yes. So how are you?
I'm fine. And you?
Alhamdulillah, I'm fine. Thank you.
Okay.
So I share my screen.
Okay.
So can you see my screen now? Can you see my screen?
Yes.
Okay. Okay. So hi and welcome to the 7 days online training session on Google Earth Engine for remote sensing analysis from beginners to advanced level. Okay, and we already covered the total 3 classes already covered. Today is our fourth number of class, and I am course coordinator. And this is our full course content. We will cover all of the full course content within 7 days. Okay, so I hope after completing this total 7 days course, you are able to do any remote sensing analysis in this course modules. So today is our fourth day, and today mainly we will try to discuss about that how you can easily remove cloud and haze from your satellite imagery. You can see when you want to work with some rainy season, or you want to work with some wet season imagery, then you can find out some cloud. You can find out some cloud and haze on this satellite imagery. Okay, so we can easily remove this cloud and haze from our satellite imagery, and we can easily get the clear condition of this satellite imagery. So today I also try to discuss about this, and it's very important when you want to make the land cover classification map. This topic is very important because when you want to make the land cover classification map and every class you want to classify it, then if the cloud is present, then this cloud pixel will be mixing with your other pixel value, and you cannot get the proper land cover classification map, and your accuracy is not so good. Okay, so that's why when you want to make the land cover classification map, you must be remove the cloud and haze from your satellite imagery. Then we also try to discuss about that how you can easily showing the DEM data. DEM means digital elevation model data, and created the hillshade and slope map using the NASA SRTM this DEM data. Okay, and then how to monitor the land surface temperature monitoring using MODIS satellite imagery and make the time series chart for observing the land surface temperature condition. Then how to calculate it, the average, maximum, minimum NDVI, any specific region. So this is our total 4-day course content. So we will cover step by step. So first of all, how to remove cloud and from your satellite imagery. So here you can see this is the first satellite imagery. In this satellite imagery, here you can find out some cloud. You can see this is the white pixel value. This white pixel value identify there is a cloud pixel. Also you can see this image is not clear, but when I want to use here the cloud max function and remove the cloud, I can get totally clear condition image. Here you can see this is the image, this is the same image, but in this time, in this image, I use here the cloud marks function and I remove the cloud and haze. So that's why in this time, in this image, I get totally clear condition of the satellite imagery. Okay, so now I will try to discuss about that, how you can easily remove the cloud and haze from your satellite imagery. So for this, I simply open my code editor. In this time, I want to work with, suppose, Sentinel-2 satellite imagery. Okay, so when you want to work with the Sentinel-2 satellite imagery, so you can simply search here the Sentinel-2. I simply search in my data, I simply search my satellite image Sentinel-2. Okay, so here you can get all of the collection. I want to use the multi-spectral instrument Sentinel. You can see this is my collection. I want to use this satellite imagery and remove the cloud and haze from my satellite imagery. Okay, so for this, in this time, I simply import this Sentinel-2 satellite imagery in my code editor. You can simply click to here, import this data image will be imported, or you can simply copy this collection snippet, simply copy and then paste here. Okay, after this, you simply put a variable name in here. So I simply put the variable name is that, suppose, you can use any variable name. I simply use the variable name is the S2A. You can use any variable name. Okay, I simply use the variable, and now this collection of Sentinel-2 whole collection, it's stored in a variable S2A. Okay, in this time, I also need to import my shapefile, my boundary shapefile. So here I already imported my boundary shapefile. In this time, I want to work with this boundary shapefile, suppose Dhaka. Here you can see this is the Dhaka shapefile. I want to use this shapefile and I want to remove the cloud from my satellite imagery. Okay, so I simply click to import. Here you can see now this shapefile, boundary shapefile, is imported in my code editor. Okay, I can simply rename. I can simply put the rename and give the name is that ROI. You can use any name. Okay, I simply put here the ROI. So here you can see this first line code is this is my shapefile or boundary shapefile. Also you can see this is the my whole collection. In this time, I want to filter my image collection. Okay, so I simply filter this image collection. Suppose I take a variable and give the variable name is that, I can simply put the variable name is that, I use here the same variable as 2a. Okay, so it's also possible. You can see under this variable I put my all of the function. In this time, I simply use a function. This function name is that, I simply put the function filter bounds. I simply use here the filter bounds. Okay, and then you can see what is my argument, geometry. My geometry is that ROI. I simply put here the ROI. Okay, so already discussed about the filter bounds function. Then suppose I also need to the filter date function. Okay, I simply use here the filter date and I simply put here the start and end date. So I simply put here the date year of 2016. I simply put here this date 1st January from, I can simply put here this last year is 2016 December 31. I can simply put this date, and I also filter this image properties. I simply get the image. I simply use the filter. Then how I can filter? I want to filter Earth Engine filter less than. Okay, so what less than what? I simply put here the image properties. Here you can see this is the image properties. I can simply go to here image information sheet. Here I can get all of the image properties. I want to use here the cloud pixel %. Okay, copy this variable and just simply put here less than. Then I simply put the value. Suppose in this time I want to need the high cloudy image because I want to remove the cloud. Okay, so I simply use here the 90% cloud. Okay, cloudy image, and then I want to check how many images will be available here between this time period. I can simply copy and then paste here, and then I simply use here the size function and then click to the run. Okay, so now you can see how many images will be available. You can see for the region of Dhaka city between this time period, and also you can see between image specific image properties, cloud pixel percentage 90%. I find out the total 60 images. Okay, in this time I want to work with this total 60 images, so I simply use a function. From the 60 image I simply use the median imagery. Okay, then I simply clip with my shapefile. I simply use the clip, and then I simply call the ROI. Okay, clip with ROI. In this time I want to show the result in my map interactive view. I simply use the map.add layer, and this is my object name. Here you can see all of the argument. In this time my object is the S2A. I simply copy this variable and then paste here. Okay, and then I simply remove all of the details you can see. And I also want to centering this shapefile. I simply use the map.center object. Okay, and this is my ROI, and then click to the, I also center zoom level is that 10, and then click to the run. So here you can say I can get the image, but this image is not this visualization is not good. I can totally get the black color image. Okay, in this time I also add here the visualization. Okay, so I simply click to here. So I simply, you can see, I simply click to here this setting button, then I can use the different types of band combination in here. I simply use here the suppose B4, B3 and B2. This is the true color composite. Also increase the stress 98%, and then I simply click to the apply. So now you can see we can get the imagery of the, you can see this is my image of Sentinel-2 for my Dhaka city region. Here you can find out lot of cloud. You can see this is the cloud pixel. Also you can see this is the cloud pixel, cloud pixel, cloud pixel, cloud pixel, and also you can see some haze in this imagery. Okay, so in this time I want to simply import the visualization parameter in here, then simply copy and then simply paste after the name, and also put this is the cloudy image. I simply use here this is the cloudy. Okay, I give the layer name. Here you can see I can get the image. You can see this is the cloudy image. I can find out the cloudy image, and here you can see total 90% of cloudy image. If I want to increase the value, suppose 100%, then you can see what happened. Then in this time you can also find out the some lot of cloud in this time. You can see now increase the cloud pixel percentage in here. Okay, so here you can see lot of cloud. Okay, so you can see this is the lot of clouds in this time. In this time, suppose I want to remove this cloud and haze from these images, and I want to get the clear condition of satellite imagery. Okay, so for this, when you want to remove the cloud and haze from this satellite imagery, first of all you find out the cloud max band. Okay, so here you can see band, and you can simply go to the below. Here I find out a band. This band you can see name is the cloud max. This band description is the cloud max, and this band name is the QA60. Okay, so here you can see this is the cloud max band, and this cloud max band has a 2-bit, bit 10 and bit 11. So here you can see bit 10 has a 2 option. First you can see this is the 0. This 0 bit it represented the no cloud, and 1 it represented the cloud, present cloud. Also you can see bit 11 it's called the cirrus cloud, and it has the also 2 bit. You can see 0 it represented there is the no cirrus cloud. Also you can see bit 1 it represented there is the cirrus cloud present. Okay, so in this time I want to work with this band QA60, and then I set the 2-bit, bit 10 and bit 11. Every bit I want to use here the 0 bit. You can see I want to set the 0. It means that there is the no cloud, or also you can see 0 it means that there is the no cirrus. So my first task is that I simply use this band QA60, and then I simply select the 2 bit 10 and bit 11. After this I simply set the bit 0, because you can see 0 represented there is the no clouds, also you can see there is the no cirrus cloud. Okay, so in this time I want to work with this. First of all I need to select the QA60 band, then need to select bit 10 and bit 11. After this, from the bit 10 I set equal to 0, also bit 11 I set equal to 0. Then I can get the clear condition of satellite imagery. Okay, so let's go, we write the code. In this time we need to work with a function. Okay, so I simply make a function in here. So for the function I can simply use the function keyword and then give the function variable name is the max to cloud. This is my function variable name. You can use any name, no problem. Okay, then I simply use here the parenthesis. In this parenthesis I simply put here my element name, suppose image. Okay, element name can be anything. Then I simply use here my curly bracket, and between this curly bracket I just put my argument what I need. My first argument is that I want to select this band. I want to select this band QA60. I want to select this band QA60. I simply copy this band name, and then I simply take a variable and give the variable name is the QA. You can use any variable name. Then I simply call my image element name. You can see this is the element name, image. Then I simply use here the select function and then put here the band name QA60. Okay, then from this band QA60 I also need to select the bit 10 and bit 11. I want to select bit 10 is the cloud and bit 11 is represented the cirrus. Okay, so I simply take a variable and give the variable name is the cloud bit max. You can use any variable name. I simply use the cloud bit max. Then I simply use here the 1, then less than 10. This is the bit number of cloud. You can see this is the bit number of cloud. You can see this is the bit 10. Okay, and then I also do for the same thing for the cirrus. I simply take a variable and give the variable name is the cirrus bit max. Okay, and then I simply do there 1 less than 11. Okay, so I simply select my 2 bit 10, it represented the cloud bit max, and bit 11 it represented the cirrus bit max. After this I also need to max. Okay, and I simply take a variable and give the variable name is that max. You can use any variable name, and then I simply call a QA, because you can see this is the QA. It stored my band QA60. Then I simply use the function bitwise AND. Okay, bitwise AND with this. You can see. So I simply use the bitwise AND. This is the function. This function connecting the cloud bit max. I simply use the cloud bit max connecting and set equal to 0. Okay, so here you can see I simply call the QA. This is the variable. It stored the QA60 band. I simply use the QA. Then I simply use the bitwise AND, because I want to connecting the cloud bit max. This is the cloud bit max. This is the bit 10, and I set here the equal to 0. Okay, and also do for the same thing. So I simply use here the AND function. Then I simply use here the QA. Then simply use here the bitwise AND, and then in this time I simply call the cirrus bit max, and then paste here, and then I simply use here the equal to 0. Okay, so here you can see in this time what I can do. First of all I simply select my band QA60. This is my cloud max band. Then I simply select the cloud bit max 10 and cirrus bit max 11. Then I max two things. Here you can see QA bitwise cloud bit marks equal to 0 and QA bitwise and Cirrus bit marks equal to 0. It represented, this is the clear condition. Here you can see it represented 0, set equal to 0, there is the no cloud, there is the no cirrus. So I simply set equal to 0. Okay. So in this time I want to also need to add a function, this function called the return function. What I want to return from here. In this time I want to use here the update marks function. Okay. So I simply call my image element name and then simply use the update marks. Okay. And then I simply use here the marks. Okay, you can see I simply put the copy the variable name and paste here marks. Okay, so this is the update marks. So now it will be updating and I can get the clear condition of satellite imagery. So here you can see in this time I also run this code. So for this I just simply copy this line. Okay, you can see this is my cloud marks function. Okay, and now I want to add this function with my whole collection. Okay, so I simply put the, suppose this is the S2. Okay, I simply change the variable name S2, copy and paste here the S2. Okay, in this time you can see I simply call my function variable name and then I want to add with this. So I simply use here the map function and then paste here this variable name. Okay, so I simply paste here this variable name. You can see marks to cloud. Okay, this is my function variable name, and in this time you can see it will be connecting with my collection S2. Okay, and you can see QA60 and this variable name is the marks to cloud. So I simply use the map function and put the variable name. It means that this function which I created, it connecting with my whole collection. So in this time I can get here the, you can see I can simply, this is the cloudy, not cloudy, I simply not cloudy, this layer name, and then click to the run. So here you can see in this time I can get the total 2 images. We can find out, you can see what is the difference between the 2 satellite imagery. You can find out, you can see this is our not cloudy image. Okay, so this is the cloudless image. So you can see I can get the 2 layer. First is the cloudy, you can not cloudy and cloudy. Okay, so here you can see this image is the cloudy. When I click to here you can see this is the not cloudy. Okay, and you can see what is the difference between the 2 images. When I use the cloud marks function I get the totally clear condition of satellite imagery, and this satellite image is the mainly we can use for making the land cover classification map. Then we can get the better result. Here you can see this is the not cloud, this is the cloudy image. You can see this is the cloudy image, and when I use the cloud marks function I can get totally clear condition of satellite imagery. You can see this is a clear condition of satellite imagery, and
is this resolution of?
Yeah. So do you have any question? You can ask me. Any question or any doubt? You can ask me.
Okay. Is this not cloudy resolution 16 meter?
No. So then
Okay.
we can use here the cloud, and this is the wavelength is a 60 meter. Then we can get totally, you can see totally you can get the clear condition of satellite imagery. When I add the cloud marks band function, you can see also has will also will be gone. Okay, and
Okay.
you can see this is a cloudy not cloudy and cloud free image. We can easily, and you can easily download this image easily for work with the ArcMap software or other software. We can easily do it. Okay, so mainly you can see I will try to show you this part in the Sentinel-2. If you want to remove the cloud from the Landsat, this is the same way. Landsat has another cloud marks band. This band name is the Pixel QA. Okay, we can apply the same procedure. Okay, also you can see this is the Pixel QA. Also you can find out some the bit 10 11 4 5 7 bit number. Also you can see this bit number has also some sub bit 0 1 2, 0 means there is the no cloud, 1 means the presence of cloud. Okay, like this we can easily find out this. Okay, so I hope you can easily understand about this topic, how you can easily remove the cloud and haze from the satellite imagery, and you can get the totally clear condition of satellite imagery. You can see this image is not clear, this image you can see lot of cloud, also you can see haze. When I use the cloud mask function, I can get the totally clear condition of satellite imagery. Okay,
Okay, can you try for Landsat?
okay, you can also try it, and when you face any problem I will help you. So this is your homework. Okay,
Okay.
so you can try it, and this is same way. But when you face any problem, then you can just call me anytime about the
Okay.
topics. I will help you, no problem.
Okay.
But I want you can also try. Okay, so you can see,
Okay.
and this same way.
Okay.
Okay, so I can see Sentinel-2. Okay,
Okay.
so in this time I will go to my next slide, and I also send you this practice code, so you can easily practice, no problem. In this time I also try to discuss about the land surface temperature monitoring using the MODIS satellite imagery. Okay, so here you can see this is the land surface temperature monitoring for the Dhaka city. Here you can see we can find out the land surface temperature in degrees Celsius. Okay, so here you can see the red color, this is the red color, you can see high red color, this indicating the high temperature, land surface temperature. Also you can see the blue color, it represented there is the low cloud pixel. Also you can see we can easily make this time series a chart also like this. Okay, also you can see this is the time series chart of the land surface temperature monitoring. We can easily make the time series chart, and we can also download this time series data. Okay, so in this time I also try to discuss about that, how we can easily work with the land surface temperature monitoring from satellite imagery. Okay, so mainly we can use here the two images. If you want you can use the Landsat image, if you want you can also use the MODIS image. Okay, so I also try to discuss the both images which you can easily use the monitor the land surface temperature using the Landsat MODIS also Landsat imagery. Okay, so in this time I also go to my code editor.